In the second part of our lesson, we're going to be solving rational inequalities. The only difference between a rational polynomial and a rational The only difference between a polynomial inequality and a rational inequality is we have to include our undefined points in our sign chart. So when is this undefined? Well, it's undefined when x equals 6. It's undefined when x equals -1. Now let's solve for x to find the zeros. So then I'm going to multiply everything by x minus 6 times x plus 1. So then I'm going to get 4 times x plus 1 times, or not times, plus 2 times x minus 6. And that's going to equal to 0, because 0 times anything is 0. So let's simplify. So we get 4x plus 4 plus 2x minus 12 equals 0. My 12 kind of ran together there, so let me rewrite that as 12. And then 4x plus 2x is 6x. And 4 minus 12 is -8. And then I add 8 to both sides, so I get 6x equals 8. Divide both sides by 6. So x is 8/6, or 4/3. So now what I'm going to do is I'm going to make my sign chart. And I'm going to have 3 points in my sign chart. That is, I'm going to have -1. And I'm going to put a U here for undefined, because I know we're not going to include -1. I'm going to have 4/3, and I'm going to have 6. So I'm going to have 4 parts of my graph, and once again, I know it's undefined at 6, so I can't include 6 in this part. So let's pick a test point, and once again, I like to pick 0, because nice things happens with 0. So I'm going to put 0 is going to be between -1 and 4/3. So here's my test point. So I put in 0. So then what happens? What do I get? Well, I get 4 over -6, or -2/3, plus 2 over 3, because if I put in 0, let's try that, plus 2. Let me explain that. I didn't explain that very well. I put in 0 for x, so I get 0 plus 1, so I get 2. And I don't know why I put, and then, so I get -2/3. Well, notice 2 minus 2/3, that equals to a positive number. So that part is true. So in other words, this part of my graph is true. So I know this is false. It goes false, true, false, true. So my answer is, now we got to be careful with our undefined. You can't include undefined. So I'm going to say my answer is going to go from not including -1 up to 4/3, but it can equal 4/3. No, it can't equal 4/3. I want it to be greater than 0. So union, and then I'm going to go from 6 to infinity. And there's our answer. And we can verify that by graphing too. And when is my graph greater than 0? Well, my graph is greater than 0 in 2 parts. We've got this part right here, and then this part right over here. And that's what our answer is. Now let's take a look at an application problem. It says a carpenter is making tables. The tables have rectangular tops with a perimeter of 20 feet and an area of at least 24 square feet. Write and solve an inequality that can be used to determine the possible lengths of the table. So let's draw a picture out here. So I've got a table. And I don't know much. I know it has length and width. Okay? So I know the perimeter is exactly 20. So I know 2L plus 2w equals 20. I know the area is at least 24, so I'll say L times W equals, nope, not equals, because I said it's at least 24, so I want it to be greater than 24. Well, I've got a system here, so let's use substitution. Since I got my first equation, let's get one letter by itself. So I'm going to solve for L. So L is going to be 20 minus 2w all over 2, right? Because I subtract the 2w and I divide by 2, which is actually the same thing as 10 minus w. So then I'm going to substitute 10 minus w in for L. So then I'm going to get L, which is 10 minus w, times w is going to be greater than or equal to 24. Now we can solve this in a couple different ways. Let's distribute. So I'm going to get 10w minus w squared is greater than or equal to 24. And then what I'm going to do is I'm going to make it equal to 0. So I'm going to move everything to the right side. So I'm going to have 0 is greater than or equal to w squared minus 10w plus 24. I can factor that one to find the zeros, can't I? So I'm going to say w minus 6 and w minus 4 would be my related functions. My zeros are a w equals 4 and 6. So here's 4, here's 6, and then I'm going to pick a test point. And I will, once again, I like 0 as my test point. So I'm going to pick, my test point here is 0. If I go and I put that back in, if I put in w is 0, so then I'm going to get 0. I think I'm going to write this down so you can see it. So I'm going to say, is 0 greater than or equal to 0 minus 10 times 0 plus 24? And I get 0 is greater than or equal to 24. That is not correct, so that part's false. So it's between 4 and 6, and then I know anything bigger than 6 is true. Now, remember, it can be 24, so I can include, so w is going to equal any number from 4 to 6. It'll meet my conditions.